Okay, so I have a history in my career of looking at things differently than anyone else, so I did that here too. I'm also, because I'm a systems engineer, figured the topic I was asked to address is vision for future resilient long-term extraterrestrial habitats. So I looked at it as my system engineer curmudgeonly self would look at it. And first, so system engineering starts with requirements. So long-term, if you're going to do anything long-term, you better have an economic justification. And I'm hoping to get economics into this discussion, especially with regard to Mars, because it's hard to find an economic model for Mars. So any Mars advocates, be thinking about that. We think about exploration because that's what we've been doing, and exploration is not sustainable economically. That's just something you do to find out what you can do economically. So it's really important for us thinking about long-term to think about what economically, why are you going there? Where are you going? And that means if you're looking at economics, you need to have some unique product or service that you can provide if you're doing a lunar habitat. What materials can we find there? I'm especially excited about the lunar far side. It's been pummeled for billions of years by everything that the solar system can throw at it. There's probably some impact chemistry in weird environments, bizarre temperature. There have to be new isotopes and new compounds back there. Let's go find it. Let's go get it. And I'm expecting that from that we will find some ores back there or some materials back there that we can make amazing things. Wouldn't it be great if we could make stronger turbine blades for better jet engines? So you need something that you can export for economic sustainability, like export to use on Earth, and eventually use for building for going to Mars. If you have products, who and where are the customers for whatever those products are? And the moon is far enough away that the products must be valuable enough to make the transportation costs viable, and that's the problem with Mars. It is so far away, if we found a whole crater full of diamonds, it wouldn't be worthwhile to ship it back to Earth. Okay, so we only have two charts, but we show them in kind of gradual reveal here. So, system engineer, I'm looking at requirements. This description of what we were supposed to address doesn't. I know there are assumptions, but when you're talking to systems engineers, you need to be really, really specific, or we will intentionally misinterpret. And that's embarrassing. So when we're talking about future resilient long-term extraterrestrial habitats, we need to be talking about specifically define what location are you looking at. Is there gravity? We've shown both surface and gravity or zero gravity environments. Do you need artificial gravity? If you're going to the moon with people, you probably need that. We need to experiment with that. If you're on the surface, what kind of vehicles do you need? Are you doing mining? Are you interacting with other habitats? And power is a biggie. If you're doing refining or manufacturing or making things, it takes a lot of power. Just look at an aluminum plant. And is there existing infrastructure? Now, in the space settlement design competition, or because I run the space settlement design competition where we have high school kids respond to an industry-type request for proposal, where we define the economic model for the specific settlement we're asking them to produce. We write future history, describing in the competition year, if we're in the 2050s, wherever we are, what have humans done to that point? We invent products made from space resources to provide an economic rationale. And what I'm realizing from going to conferences, especially sponsored by the National Space Society, is there's a lot of infrastructure, like providing air. The way we've done space projects, we've done them like a movie production. I lived in the LA area for many, many years, and the way a movie production works is the executive producer and the producer buy or make the sets and all the stuff they need to do the movie. And when the movie's over, it's all gone. Aside from maybe the radios that they could use on another movie, it's all gone. And that's how we've been doing space programs. We haven't been treating this stuff like infrastructure. So every new space project has to do its own air revitalization system, and its own recycling system of wastes, and its own how you get water, and all these things. What I'm starting to see in let's call it the space settlement technical community, mostly through National Space Society, There are people working on how to use lunar resources to provide infrastructure. We are going to get to the point where we will buy air as a commodity. We will buy a recycling system as a commodity. We will buy water as a commodity. There will be a packaging system for delivering water. There will be vehicles. You'll buy vehicles, or vehicles will deliver. So we need to look at, when we're looking especially long term for extraterrestrial habitats, what infrastructure is going to be around that we don't need to develop new. Vehicles, commodities, all that kind of stuff. Okay, next chart. So after we identify all of that stuff, then if you're looking at habitats, depending on what you're going to be doing, how many people, what are they going to do, what do they need to do, what they need to do, more requirements, requirements, requirements. So when you get into industry, those of you who are students, when you get into industry, there's going to be some naggy system engineer who won't let you start designing right out of the box. Get the requirements first. So I'm your naggy system engineer today. Resilient, now that's a word that I really hadn't heard in industry. Engineering RFPs tend to define design lifetimes. And so there are design lifetimes on things like bridges and dams and B-52s. Now, bridges and dams and B-52s usually are in operation long beyond their design lifetimes, especially B-52s. I mean, there are probably going to be B-52 pilots that are not born yet, okay? And how long we've been flying B-52s? Like 70-some. So, I mean, B-52s could be 100 years old and still flying and doing useful thing. So what that means is there are subsequent contracts for upgrades to those things to increase their design lifetime. But you talk about resilient, it's more like a lifetime kind of thing. But we've actually had some addressing. Lindsay mentioned dust. That dust, that lunar dust especially, that is nasty, icky, rotten, crappy stuff. And it really only came out on suits. What, last 10 or 15 years it got into the public. The Apollo suits, the longest any of them was used on the surface was what, 24 hours? They came back trashed. I mean, there were joints that were frozen, catch me if I'm wrong, joints that were frozen, joints that were leaking, abrasions, leaks. Had we gone another 24 hours, we probably would have killed people. Maybe, maybe not. But they would have been especially like frozen joints. So what happens with lunar dust, it hasn't been blown around, so it has very sharp abrasive edges. It gets into stuff. You do not want to get one grain of that into you. If you're doing a long-term habitat, if you have 2 grains of dust come in with every airlock opening, you're going to be busting all of your mechanical rotating equipment everywhere inside the settlement or habitat in 10 or 15, 30, 100 years. If you happen to be in an orbital location, resilient means, is there a space debris problem? Is there an orbital decay problem? Is there a station keeping issue? Then you get into propellant replenishment and all that kind of stuff. So requirements, requirements, requirements. And also, depending on what your capabilities are at any one time, that will determine what your resilient might be. So I think Lindsay mentioned, more than one mentioned, that you do lose air every time you open an airlock. That's a technology we need to improve, to lose less air. And I think there was a 98% on the water recycling was indicated this morning. And what you get left, what's left, and that might be good fertilizer. There's a lot of phosphorus in it, nitrogen, and it's good stuff. So we need to get more adept at recycling everything. Power systems, you're using solar power, it deteriorates over time. So that's a big factor in resilient, and deterioration of airlocks and mechanisms due to local dust. So that's my last chart, but basically I'm the question asker, saying if we're looking at our ideas for future resilient long-term extraterrestrial habitats, start with the requirements. If you do a really good job of establishing your requirements, you can do a really good job of establishing a design. Thank you.
I understand and appreciate the reliance on requirements, but at what point do you as a systems engineer believe that we have enough requirements to start the design? At what point can we cut off the requirements and start building so we don't just get a requirements spiral?
Oh, that's a really good question. So I've been writing RFPs for the design competition. It kind of depends on, as I'm writing requirements, I'm thinking of a solution, not the solution, and you write enough requirements to enable you to get the solution you want. So, but that's an excellent question, because it's very easy to get all wrapped up in requirements writing, and it never ends. And yeah, we all know systems engineers who do that. So yeah, you need to decide, when have you written enough. I actually wrote an RFP for a cargo container system on Space Shuttle, and the contract was with Scale Composites. So I talked with Bert Rutan, and he did a little bit of shuttle bashing, and that's okay. And he said, Bert, the reason we're with you is because we want you to help improve space shuttle operations. And he lowballed the estimate, because he knew that, he figured I'm with Space Shuttle, so it's kind of NASA-like. He knew that there's always requirements creep, and they would make it on the change orders. I wrote an RFP that did not need to be changed all the way through the whole contract. So it's possible to do. And they didn't raise the price.